This last one violates one of the properties of simplified radicals, and that is that the radicand can't have any fractions. And right now, I have a radicand of 32 over 3. So let's use our quotient property to break that up and then deal with each piece separately. So I'm going to just make a note here temporarily that this is a square root, just to remind me of that. And using the quotient property, I'm going to go ahead and say that this is the square root of 32 divided by the square root of 3. So I no longer have a fraction under my radical symbol, but now I'm violating another rule, and that is that the denominator of a fraction can't have a radical. And I've got that pesky square root of 3. So let me show you a really cool trick to get rid of that radical. If I had, instead of just a square root of 3, if I had a square root of 3 squared instead, well, the square root of 3 squared is 3. So let me show you how to get that. Here's the first step. We're going to multiply by a special form of the number 1. I really would like to have another square root of 3 here so that I have square root of 3 times square root of 3, which will give me 9, and that's a perfect square. But if I do that, this is no longer the same expression that I started with. However, if I also multiply the top by a square root of 3, well, we know that anything divided by itself is just 1. So this is really just a special form of the number 1. It doesn't change the value of the expression at all. It's just changing the form of the expression. I have simply multiplied by 1, and anytime you multiply something by 1, it's still that thing. Now what I'm going to do is use my product property and go ahead and multiply across the top and across the bottom. So I'm going to say 32 times that 3, and then on the bottom of the fraction, I'm going to have the 3 times the 3 that I just added to it, or multiplied by. So let's continue working on this. I know that 32 times 3, or if I don't know, I put it in my calculator, is 96, and 3 times 3 is 9. So I'm going to have square root of 96 divided by 3, because the square root of 9 is 3. We now have taken care of 2 of our properties for simplifying. We don't have a fraction in the denominator anymore, and we don't have a radicand with fractions. This piece that we just did here is called rationalizing the denominator. We're creating a rational number. So you could make a note there. So now that we've rationalized the denominator, the last thing we need to do is check 96. We have an index of 2, so we will be looking for sets of 2 or pairs. So let's take 96 and break it down. 96 can be broken down into 3 and 32, and 3 is prime. 32 can be broken down into 8 and 4, and I got to keep going on both of these. 8 can be 4 and 2, and 4 is 2 and 2. Finally, I need to take care of this last 4 and make it a 2 times 2. So again, we are looking for sets of 2. We're looking for pairs. And so I see a set of 2 2's here, and I see a set of 2 2's here. However, I have a 3 and a 2 that don't have anything to pair up with. So those 2 will pair together, but they're going to have to stay under the radical. So let's go ahead and rewrite this. We are going to have the square root of 4 times the square root of 4. That's going to take care of this pair of 2's, 2 times 2 is 4, and this second pair of 2's, another 2 times 2 is 4. And then I need to say what everything else is. And my everything else is a 3 and a 2, so 6. Remember that this whole thing is replacing the 96, but I still have that 3 from the original expression that I was looking at. So the whole thing is over 3. Now let's continue simplifying. The square root of 4 is 2. Another square root of 4 is 2. I have that 6 under a square root that I can't do anything with. And finally, the whole thing is divided by 3. One last thing I can do to simplify, and that is multiply the 2 times 2. That'll give me 4. And then I have a square root of 6. And all of this is over that 3 from the original piece right up here.